this lecture video, we're going to learn about linear systems, and the one way we're going to solve the system is by graphing. So to start us off, we're going to do an example where we are given x plus y equals 1, and another equation, x minus 2y equals 4. Now, this is a system of equations. We have only two equations, and in order to solve for get like some sort of value, we need two equations for two variables. If we had three variables, we need three equations, four variables, four equations, and so forth, in order to have a nice single solution for our course. So x plus y equals 1. Let's go ahead and call this guy equation 1. And we are going to graph him. So we have x plus y equals 1. In order to graph him, usually you can either find x-intercepts and y-intercepts. You can plug in points. I personally think the easiest way is to put it in the form y equals mx plus b. So we'll subtract x from both sides of the equation. And we have a negative 1 for our slope and 1 for our y-intercept. So when we graph it, we're going to have a point at the y-intercept of 1. And then we can use the slope, which says go down 1 over 1, to get another point, which conveniently is the x-intercept. And you can keep going down 1 over 1, down 1 over 1. Or you could go up 1 and to the left 1. You've formed your line, and I'm not the best drawer of lines, so bear with my squiggly line. I did too bad there. So this is equation 1. He's in the red. Now we're going to go ahead and graph equation 2 here. Same idea. I'm going to go ahead and solve for y because that's how I prefer to graph. You can use any method you like to graph though. So I'm going to subtract x from both sides of the equation. And then I'm going to divide by negative 2. And what I do to one side, I have to do to the other. So I'll divide negative 1 by negative 2 gets us positive 1/2. Positive 4 divided by negative 2 is negative 2. So we have our y-intercept at negative 2. And we can use our slope, rise 1, run over to the right 2. Up 1 over 2. You could also go down 1 to the left 2. Doesn't matter as long as you get something with positive slope, because we have positive 1/2 as our slope. And where these two graphs intersect one another, and it happens to be at this point right here where they overlapped, is the solution to the system. That point is, and since I drew on a grid, I can see it's positive 2 for the x-coordinate and negative 1 for the y-coordinate. So our solution for this system of equations is an ordered pair where you're given the x-coordinate first, then the y. Now, to expand a little bit more on what this means, let me get another blank page here and clear that out. So we had a solution of positive 2, negative 1. And our two equations, we had x plus y equals 1, and we had x minus 2y equals 4. We can check our solution to see if we're correct by plugging it into the equation. So instead of x, we can plug in 2. And instead of y, we can plug in negative 1. So we'll start off where we have x plus our y, which is negative 1. And we want to know, does that in fact equal 1? And we're not sure, so I'll put a question mark. 2 plus negative 1 is 1. 1 equals 1, so this checks out. That's good. Now we can go ahead and check our other equation. And we have x is 2, so we'll plug in 2, minus 2 times our y, and y in this case was negative 1. And we want to see if that does in fact equal positive 4. Well, negative times negative is positive. 2 plus 2 is in fact 4. So yes, this ordered pair satisfies both equations. And that's what makes him the solution. That's how we'll find the solution by graphing.